So in this video, we're going to actually talk about the package challenge. So I've already actually pasted in the challenge for you to actually do. And going through it, we need to create a suitably named package containing a class called series. And that class should have the following static methods. First one's endsum, which has actually got an int n parameter, and that actually returns the sum of all numbers from 0 to n. So then the first 10 numbers, to give you an idea, are 0, 1, 3, 6, 10, 15, 21, 28, 36, 45, and 55. The second static method is factorial, which also accepts an integer, and that should return the product of all numbers from 1 to n being the parameter, of course. So i.e. 1 times 2 times 3 times 4, right up until n take 1 times n, as you can see on the screen there, multiplied. So the first 10 factorials are 0, 1, 2, 6, 24, 120, 720, 5040, and so on. And the last one, Fibonacci, the Fibonacci static method returns the nth Fibonacci number. And these are defined, as you can see there, with that algorithm. F0 equals 0, F1 equals 1, and then Fn equals Fn take 1 plus Fn take 2. So there's actually the algorithm for Fibonacci on the screen there. And you can see in that case there, F2 is also 1. So the first 10 Fibonacci numbers, 0, 1, 1, then it's 2, 3, 5, 8, 13, 21, 34, and 55, and so on. So once you've actually tested your functions, delete the main class and actually produce a jar file. You want to create a new project and add your series library to that project, and then test the 3 methods in the main method of your new project. And what you want to do is actually use this code, which I'm going to paste in when you actually test it. That'll be the code there. Now that obviously won't work at the moment because I haven't actually created and added the library, the series library yet. But that will be how you'll actually go about actually testing your code. And as you can see, again, they are static methods. So that's the challenge. So now it's your turn to actually see if you can solve this challenge. Go away and actually create the series class and the 3 static methods and do some testing, create a library. And when you're ready to actually come back and actually see the solution, start the video again and I'll go through it. So pause the video now. Okay, so how did you get on? Did you figure it out? So let's actually go through that. So the first part was we needed to create this package, or this class I should say, called series, and with the 3 static methods, endsum, factorial, and Fibonacci. So what I'm going to do is create a new package when I actually create it. I'm going to come up to my source and do right click it, new Java class, and I'm going to actually call this com.timberchalka.mylibrary.series. So the class name is series and the package is com.timberchalka.mylibrary. Click on OK. And you can see we've got the new package created and the class also created. So let's actually go about now creating the 3 methods. So the first one we're going to start with is the endsum. And endsum is a matter of is the easiest of the 3. So it's public, static, returning a long, endsum, int n, returning a long because it's basically can accommodate a larger number if we want to go higher. And the actual method, if we go back to our code again, to our example, endsum returns the sum of all numbers from 0 to n to whatever was actually passed, n being the parameter. So to return that, all we need to do is return n multiplied by n plus 1 divided by 2. And that actually should give us the answer. And we'll test that shortly. We'll actually write the 3 methods, test them, and then we'll actually create the actual library. So going back to our main, the second one was the factorial. Return the product of all numbers from 1 to n, i.e. 1 times 2 times 3 times 4, etc., right up until n take 1, or multiplied by n take 1 times n, as you can see there on the screen. And it gives you some examples of the first 10 factorials. So the code for that, still pretty straightforward. Public, static, long, factorial, int n, because that's the parameter of course. Now firstly we need to do a test for 0, so if n is equal to 0, we can actually just return 0, because obviously we can't calculate anymore. Otherwise we're going to actually start with the value 1, and then we're going to do a for loop and actually go through and multiply that, or add to that the multiplication for each one. So to do that, we're going to go for int I equals 1, I is less than or equal to n, then I++, and then we just do fact equals fact multiplied by I. And then we return fact. You can see there. That's actually it. That's the factorial. And the last one we need to do now is the Fibonacci. And just going back to our overview, returns the nth Fibonacci number, and you can see there the way we actually calculate it. So Fn equals Fn take 1 plus Fn take 2. And F2 in this example is also 1, and we got the example of the first 10 Fibonacci numbers there. So let's go ahead and do that. Public static long Fibonacci int n. So we start off doing a test for 0. So if n is equal to 0, just like the factorial, we can actually return 0. Sorry, return 0. But else, if it's 1, we can actually also return 1. So basically, if it's 0 or 1, we're returning those hard-coded numbers, 0 or 1. But if we get to here, we know that the number has to be 2 or higher. So I'm going to put long n minus 1 equals 1. Long n minus 2 equals 0. So that's the initial values, because we're going to take the number minus 1 will be 1, because we're going to be getting a number that's at least 2 or higher, and n minus 2, we're just going to start off with 0, because of course n being 2, n take 2 is going to be 0. So basically we're initializing that with the two values, assuming the number was 2, and then we run through our for loop. So we put for int I equals 1, I less than n, I plus plus. Then we calculate it as fib equals n minus, and I need to create a variable long for fib equals 0. Fib equals n minus 2 plus n minus 1. And then we put n minus 2 equals n minus 1, because we're incrementing the loop. Then n minus 1 equals fib. So basically we're setting fib initially to n minus 2 plus n minus 1. Then we're setting n minus 2 to equal n minus 1. And as you can see in the last line, n minus 1 then becomes the current value of fib. And that's it. So we let the for loop go through and complete, and then we return fib. So that should be our Fibonacci method. So now we've actually done that, it's time to actually create the actual package. So what I'm actually going to do now is actually remove the main method, because we don't want that in our file, our jar file, so delete that. So we're only left with series. I'm going to come up here now to File, Project Structure. I'm going to choose Artifacts. I'm going to add, or click on plus. I'm going to select jar from modules with dependencies. We're going to just leave the default set. There's no main class, which is correct, because we're going to write the main class to do the testing. And the jar file is okay. Click on OK. And you can see it gives us a default location. Java programs package challenge underscore jar, and we'll be looking in there shortly to get the jar file so we can actually include it in the new project we're going to create. Click on OK to that, and that's actually created. Then we can go up to build and build artifacts to make sure that the jar file is built. I'm going to select build, so that's now built, and we'll just go and check that. So let's have a look now. Package challenge. Out, artifacts, package challenge underscore jar, and there's our jar file. So that was built successfully. So now what we want to do is create a new project, and we're going to actually import this series class via the package challenge jar file into that new project. So I'm going to go back into here, file, new project, a new Java project. And I'm going to call this series test, but you can call that obviously whatever you like, but series test. Common.timberchalker. So what I'm going to do is create something completely different. So we used common.timberchalker before. Let's actually try common.example.series.test, like so. So it's a completely different base package. Click on OK, and we're going to use this window, so we can let the other one close because we're finished with that project. So we've now got this one. And the next thing we want to do then is we've got our main method, which we're going to write our test code in. We want to actually go to project structures and libraries, and we want to actually add our artifact file. So I'm going to click on Java. I'm going to go back to our challenge, package challenge, out folder, artifacts folder, package challenge folder underscore jar, then there it is there, package challenge underscore jar. Click on OK to that, and it's going to be added to the series to the selected modules. That's click on OK to that. That's fine, and click on OK. So now we've got that. We can go into external libraries, and we can see we've got package challenge, and you can see we've got our series class. So it's obviously found it, so that's good. So now we should be able to write some test code. And if you remember, I actually had that test code from before. Let's actually check this out. So we're going to go for int I equals 0, I is less than or equal to 10, I plus plus. Now let's try the nsum first. That's going to be system out, and we'll put series.nsum I. Noting that it actually found our class automatically and did the import as soon as we started using it. And you can see now it's a different import altogether, com.timbachauca.mylibrary.series. So we'll run that. And we've got the numbers. And at the start of the video, I mentioned that the numbers we were looking for was 0, 1, 3, 6, 10, 15, 21, 28, 35, 45, 55. So that's working correctly, which is good. So the next one, factorial. Let's do that. It'll be 4 int I equals 0, I less than or equal to 10, I plus plus. And we'll print out the series dot factorial for I. If we run that, and actually what I might do there is just print out some asterisks there just to indicate that just to show us there's a separator between one method's output and the next. And obviously what we were looking for was 0, 1, 2, 6, 24, 127, 25,040, 40,320 and so on. So that's obviously working for the factorial as well. That's good. So let's go and do the last one now. And the last one, of course, is going to be int I equals 0, I less than or equal to 10, I plus plus, and we're going to print out series dot Fibonacci for I. And the output we'll be wanting for Fibonacci, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and 55. So let's run that. And there we go, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. So that's actually it. So that's the actual solution. So you're now able to, if you followed along, create your own packages and use them in other Java projects. So I hope you did well with that challenge. It's now time to move on to the next part of this section, and that's all to do with scope and visibility. So I'll see you in that next video.